Good morning, friends. Myself, Rutu Patel, lecturer from Parul Institute of Engineering and Technology, welcomes you all to the active learning video session on chapter number 6, that is polymers in the engineering chemistry part. Okay, today in this session we are going to discuss our chapter 6, that is basically relating to polymer insulators and elastomers, and we will discuss the properties and so many applications depending on the type of the topic we are choosing. Let us begin with the chapter number 6, that is polymers, elastomers and insulators. In this lecture, we are going to discuss the first point, that is definition of polymer monomer, then classification of polymer on the basis of temperature, structure and functional group. Then we have the difference between thermoplastic and thermosetting plastic. Fourth point, that is classification on the basis of structure, that is linear, branched and cross-linked polymer with examples and diagrams. Next, then we will be taking up classification on the basis of functional group. Then we will discuss homopolymer, copolymer, types of polymerization, then natural and artificial rubber detail, vulcanization of rubber and its advantages, insulator and its properties and uses, and then properties and applications of the various types of the polymers. These are the topics that are covered in the engineering chemistry syllabus of the Diploma of GTU in the semester 1. Now let us begin. Why polymers are very important in the life? Our day begins with the polymer and ends with the polymer. I hope you all agree with this sentence, because you all are aware when we wake up in the morning, then we first take the things that is brush in our hand. That is what it is, a polymer. When we sleep at night, then also we sleep on the mattresses and all that, that is also polymer. So there is no doubt that polymer is finding wide applications into day-to-day life and replacing the metal. Most of the things that we are using in the life now are made up of 50% of the polymers, and that is why it is finding a wide application because of the very unique property of this polymer. Now, before discussing why this polymer is so popular, we have to first focus on what is polymer, what is monomer and how it is made. See, the one thing before learning this topic, we all should be very well aware regarding about the carbon chemistry and how the compounds are formed. For that, I will be discussing little bit detail on that, and then we will focusing on the polymer and monomer concept. So let us try to put up the basic concepts first, and then we will combine together all the things, and then we will go ahead. Now, the first thing that we have to see is carbon chemistry. You all are very well aware their carbon is having atomic number of 6. Okay, so its configuration will be 2, 4. It means in the valence shell at the most 4 electrons are available to form the chemical bonds. That is why you can see here that carbon can maximum for the 4 bonds. Okay, now apart from this, one thing that you have to select, that is one carbon compound. You all are aware that it is from the derivative of the methane. 2 carbon compound, then it is ethane. 3 carbon compound, then it is propane. Same way we can go ahead with the 4 carbon compound, that is butane. Then we have 5 carbon compound, that is pentane. Then we have 6 carbon compound, that is our hexane. 7 carbon compound, that is our heptane. 8 carbon compound is our octane. 9 carbon compound is our nonane, and 10 carbon compound is our decane. So these all things one has to keep in mind before discussing the polymer and monomer concepts. So these things are there. Carbon chemistry is very interesting. It is having atomic number of the 6. Maximum bonds that a carbon can form is 4. And apart from this, methane, ethane, propane, all these functional groups, derivatives requirement is there, so that we can study the polymer case. Now what we can do is, we can list out the things about functional group. In the functional group, you all can just recollect the past details. That is, functional groups are basically of variety that we are going to first list it down in this session. You know that CHO group is known as your aldehyde group. Then we have COOH group is known as your carboxylic acid group. Carboxylic acid. Then we have CO group, that is ketone group. Then we have OH group, that is your hydroxyl group. Then we have CONH2 group, that is your amide. Then we have NH2 group, that is your amine. Okay, all this fundamental. Apart from this, there is COOR, this is your ester group. Now what is monomer is basically, it is a simple organic compound, okay, that is containing any of this functional group. So one has to keep in mind that before discussing monomer, why it is important, because monomer is having a specific site, okay, on which reaction is occurring, and whenever reaction occurs, then what happens, there is a chemical bonding of the similar or different monomers that is going to lead to the formation of the polymers. Now why this all things are important, because you have a monomer chemistry, then you have a polymer thing. The first concept, that is monomer, we can see here. The name itself suggests that mono means single and mer means unit. And what is this unit? Unit is basically any of this functional group that is mentioned here. Now you can see very clearly here, the units can be aldehyde group, units can be carboxylic acid group, it can be ketone group, it can be hydroxyl group, it can be amide group, it can be amine group. So these are the units, and these units are basically present into your basically monomer. Okay, so now we will try to recollect the definition. As we know, look here, monomer is a simple organic molecule which form polymer by chemical bonding. Why this chemical bonding occurs? Because chemical bonding occurs because monomers are having a specific reactive functional group, and that is why they can link together to form a long chain compound, that is your polymer. So now we can recollect the polymer definition, that is, it is a large organic molecule formed by repeated linking of similar or dissimilar monomers. Means what? Either monomers can be all of the same type, or it can be having any two different functional group that will basically react with each other and form a very long chain that will form to the formation of your polymer. Now here again we can see poly means many, mer means unit. So this is the meaning of your polymer word. Mono means single and mer means unit. So that is the word for your monomer. So these two definitions has to be made clear with the help of the functional group concept and the carbon chemistry concept. Now we can see how the compounds are formed, that we will be seeing. You all can see here that suppose I want to form the compound ethene. Now how can I draw this compound? The first thing that we have to recollect from the past is ethene is a derivative from the ethane. So what we can see, that ethene will be having two carbons, right? So first conclusion that we are going to make is two carbon concept present in the ethene molecule. The second thing, that is the case when we have to see alkanes, alkenes and alkynes. Okay, alkenes are the compound having double bond, alkanes are the compound having single bond, and alkynes are the compound having triple bonds. So you can first enlist it down here, that is, if it is alkane, then what we can see, we can have that the compound having single bond. If it is alkene, then the compound having double bond, and if it is alkyne, then it will be compound having triple bonds. So these things has to be kept in mind, okay, whenever we are discussing the things. Now we can see there is a ethene molecule, okay, so that you can put it out that ethene is given to you. So one concept is clear, it is two carbon compound. The second detail we can use is ENE is there. It means what? It is alkene. That suggests that the carbon will be having double bond in the picture. So we will be putting out double bond between the two carbons. Now after this, what we will do? We will try to compensate the valency of the carbon, that is 4. Okay, now carbon is having valency of 4. So what we will do is we will try to put up, look here, this is one carbon having 1 2 valency satisfied. How much remaining? 2 remaining. So we will put here 2 hydrogens. Similarly, if you see here, 2 valency of the carbon is satisfied, so we will put again 2 hydrogens. Okay, so this is your ethene molecule. Similarly, you can take up various examples and you can recollect the information about carbon chemistry, alkane-alkene concept, and construct any molecule whatever you want to construct. Now see, you can take the another example, that is 1 propene. Now how it can be formed? You know, propene is there, it means there is a 3 carbon story. So we will write first 3 carbons. Now it is there 1 propene. It means what? The double bond is present between first and second carbon. Okay. Now try to look here. There is a single bond already present here. So now we will compensate the valency of the carbon. Carbon valency is 4. So how we have to see here? Look here, this carbon having 1 2 valency satisfied. So how much remaining? 2 hydrogens remaining. So we will put like this. Look at this center carbon, 1 2 3 valency satisfied. So how much remaining? 1 valency remaining. So that will be compensated by hydrogen. Look at this last carbon, only 1 valency satisfied. How much remaining? 3. So that will be compensated by the 3 hydrogens. So this is how you are going to construct your 1 propene molecule, and so on. You can define different types of the polymers on the basis of the alkane, alkene concepts, and with the help of that we have to remember the carbon number and the names given to them according to the carbon number. Now let us move ahead. What is the next thing? That is why polymer is finding so much of application, why it has replaced the metals in the routine life. The thing is that polymer is very much cheap. Okay, now the reason is that polymer is very famous in this today's world because of its very specific advantages and qualities that it possesses apart as compared to the metal qualities. Okay, now you can see here that polymer is very cheaply available. You can buy the things very cheaply when you try to purchase the polymer items. The second thing is, as it is lightweight, it is easy to transport, so you can easily carry it from one place to another. You all are carrying the polymer bags, all the things, plastic bottles, all these things are the examples. So it is lightweight, so you can easily transport to different places. Then very important property, that is corrosion resistant. What does it means? That it is having corrosion resistant, means unaffected by your moisture or unaffected by the water. So that is very good quality, it doesn't get corroded. The third thing, that last you can see here, it is tailor made. What is the meaning of this word tailor made? It means you can basically mold the polymer into different shapes according to your wishes. So that is why tailor made quality of the polymer has given it a great use in today's world. Then another thing very important, when we go to purchase the different things, then we always go for the colors first. We try to choose the things of the different colors, and then we think that okay, now we will taking red color, blue color, black color, depending on the colors. So these polymer items are available in variety of colors, and that is why it is going to find the tremendous application in the today's life. So now you can definitely see here that the advantages of the polymers are very much more, and that is why it is going to have finding the great application in today's world. That is the cheapness, easy to transport, lightweight, corrosion resistance, tailor made material, available in variety of the color. Now anything that you take always has a disadvantage with the advantages, right? So we have to see both the sides of the polymer. So now we will move on to the disadvantage of the polymer. You can see here very clearly, that is, it is non-degradable. Now that again depends, it is a question of the debate. Some polymers can degrade, some polymers cannot degrade. It depends on the chemical properties of that particular polymer. So that is acting as a pollutant in the atmosphere if it is not degrading in the atmosphere. So again a major question of the environment concern arises, that is, polymers are not eco-friendly. they are not eco-friendly? Because they are non-degradable, and that's why they are not eco-friendly. Now another thing that you can see, that is temperature dependent property. What does it means? Temperature dependent properties means the polymer things that we are using in life, okay, that is operating between different temperature ranges. You cannot use the same plastic material at all the temperatures. Say suppose you are using plastic bowl at home at normal room temperature, you cannot use it at a microwave temperature. So for that a special polymer has to be designed depending on its temperature. So it means what? If you try to use the polymer, then what happens? We have to see for the operating temperature also. If the operating temperature is, if you go above operating temperature, then what will happen? Your polymer will simply mash out, okay. So that care has to be taken, and depending on that, different plastic, different materials of the polymers are decided on the temperature properties. Now the important thing, that is time dependent properties. What does it signify? It says that the polymer properties are going to change with the time. Either color will fade, either material will break, all the things, all the problems are going to come with the time. It shows that the polymer is not going to live in the condition in which it was made when the time passes. That has to be kept in mind. Then the thing is that it is having low strength compared to the metal, okay. Metal is having very high strength, so again the drawback comes from the side of the polymer when it is compared with the metals. That is, it is having low strength when compared with the metals. It is having temperature dependent properties, it is having time dependent properties. That shows basically that the polymer properties has to be varied with the different parameters, and for that a special designing synthesis has to be made. Otherwise we cannot use the polymer, same polymer I should say, at all the operating temperatures, okay. You might have seen that specially plastics are designed for the microwave use, and the plastics that are designed for normal room temperature use are different. Both are having different strength. Now we will move ahead. That is how the polymers are classified. See here, classification of the polymer, okay. You can classify basically polymer on the three categories. The first category, that is basically on the basis of temperature. Second category you can see, that is on the basis of the structure. Third category that is going to come is on the basis of the functional group. The first case that we will take up